There's this phenomenon that happens in coil-based devices that's called flyback. There's a few different terms for it. Freewheeling is another one, but the simple solution doesn't cost very much and it's really easy to install. And fortunately, the designers of automation equipment have understood that. Now, where this is going to be important is in coil-based devices, like large contactors, sometimes large relay coils, large solenoids, and we want to focus on those that are DC powered. So when DC voltage is applied to these coils as an inductor, it builds up a magnetic field. That magnetic field is responsible for moving the solenoid or activating the coil, switching the contacts in the relay or the contactor. And when the DC voltage charges that inductor, it's stable. As soon as the DC voltage is removed, that inductor wants to release that magnetic field through a path of low resistance. Now, if that path of low resistance happens to be the supply circuit, as the switch is opening, there will be a point where there's enough voltage generated to spark back across. Now, that spark will then occur in the contact sets of a relay. And for these clear relays, if they're driving a large solenoid, you can actually see those in a control cabinet if the light is turned off. So how do we fix that? Well, we look at the device that's responsible for causing the spark in the first place. So we might look at that large coil, or we might look at the coil of these relays. Now in this relay, even though it's small, we can still have that problem. Now I've removed the relay from its base, from its holder, and I can also remove this other piece from its holder. This is an add-on accessory. Not all relays will have this, but it's called a diode. And here we can see on the device is the print schematic symbol of an electrical diode. Now inside, these are what diodes really look like. They're very tiny devices and they're very inexpensive. So this is not a difficult or expensive solution by any means. But when we connect a diode in parallel but in reverse with the coil, instead of the coil, that electromagnetic coil, wanting to release the energy around the supply circuit, it simply releases its energy around this diode, and the energy is released in a nice little circle that's made of the diode and the coil itself, harmlessly dissipating all of that energy instead of sending it back to the supply that it came from. So if you have a PLC that relies on relay outputs, and those relay outputs are driving large solenoids or contactors, and you're continually experiencing those relays being disabled or faulting or being destroyed, you might want to consider adding diodes in parallel with each one of those coil devices, preventing that flyback or that freewheeling phenomenon that can damage relays.